So ionic equation for a displacement reaction, in which we are going to discuss the reaction of displacement reaction of metals. Okay, you can see here zinc is more reactive when it is added to copper 2 sulfate solution that is blue in color. It makes zinc sulfate that is colorless solution, and copper is being displaced that will appear as pink solid or brownish pink solid in the solution. Okay, so this shows zinc is displacing copper from its compound to make zinc sulfate plus copper. Okay, so this is a displacement reaction. Now we can make its ionic equations. We will write zinc as it is because I told you that solid, liquid, and gases do not split into their ions. Only ionic compounds like salt solutions, alkalis, and acids, they split into their ions. Okay, copper being a compound and in an aqueous solution having copper 2 ions and sulfate ions. Okay, now here we have zinc sulfate compound. So it contains zinc ions plus sulfate minus 2 ions, or 2 minus ions plus Cu. Okay, now which 2 ions are common in this equation, Mariam?
The oxide, like SO.
Which 2 ions are common in both sides of this equation?
SO4.
Yeah, SO4 ions are common in this equation, so they will be cancel out. They will cancel out each other like this and this. The rest of the equation will be used to make ionic equations, or that will give you the ionic equations. Okay, so how can we write the ionic equations now after doing this? This is how to work out ionic equations, Abdullah. Zn will written as it is because it is a solid. Copper 2 sulfate will split into its ions copper 2 ions plus sulfate ions. Zinc sulfate will split into its ions zinc ions plus sulfate ions, and copper will written as it is because it is solid now. So in this equation, sulfate ions are common in both sides of the equations, left and right hand side. So they will cancel each other. Okay. The resultant equation will be like this: Zn plus Cu2 positive. It makes Zn2 positive plus Cu. Okay. So how this reaction is a redox reaction? You can see here zinc is changing from zinc to Zn2 positive ion due to loss of electron. This is oxidation. This is Mariam, this is oxidation. Okay. And copper 2 ions are changing into copper by the gain of electrons. That is reduction. That is reduction. Now in this reaction, zinc is losing electron, is being oxidized. From where this zinc is getting electron, it gets electron from copper. So copper ions are giving electrons to zinc. So here in this reaction, the copper ions will act as an oxidizing agent. Okay, because they are gaining electrons, they are removing electrons from zinc. Copper 2 ions are oxidizing agent as they remove electron from zinc metal. Zinc is being oxidized because of copper 2 ions. So copper 2 ions are oxidizing agent, or copper 2 compound is an oxidizing agent. But here zinc is giving electrons to copper to reduce it into copper copper 2 ions are reduced by zinc to form copper. So zinc is acting as a reducing agent. We shortly write it as Ra for reducing agent. Okay. So zinc metal is more reactive than copper. So I have already told you that reactive metals are good reducing agent. Reactive metals are good reducing agent because they can easily lose electron and they can transfer electrons to other less reactive metal ion. Okay. So zinc is a reducing agent here, whereas copper 2 ions are oxidizing agent. Zinc is being oxidized and copper 2 ions are being reduced by gaining electrons. So this is a redox reaction. This is a redox reaction. This is a
redox reaction.
And it is also a displacement reaction. क्या है ये?
Displacement reaction.
Displacement reaction. Very good. This is a displacement reaction, and which zinc, being more reactive, is displacing copper 2 ions from its solutions to form copper, and zinc compound is formed, and zinc compounds are colorless. Okay, zinc compounds are colorless in solution, whereas copper 2 compounds like copper 2 sulfate, etc., are blue in color. So this in this compound, and this in this reaction, sorry, this the compound of this color fades away or turns blue to colorless. Blue to Mariam, it changes from blue to colorless. Okay, and this pink metal is deposited, pink or brownish pink, or sometimes we can say brown metal is displaced or deposited in the reaction mixture. Okay, and IGCSE and GC is, you people have to remember some colors of the compounds as well. Okay, later on I will give you a list of colors of different compounds which are required in IGCSE or GC exams. Okay.
Okay.
Okay, beta. So now I will move to the next question from this worksheet. So which ionic equation represent a redox reaction? That answer is D, and I have already explained it in detail. Okay. And question number 8, in which reaction is the underlying substance behaves as an oxidizing agent? Oxidizing agent that cause the oxidation of another substance. Okay. So in first A, barium chloride react with sodium sulfate to make barium sulfate plus 2 NaCl. It is not a redox reaction because none of the element is changing its oxidation state. Okay. Whereas in the second reaction, copper 2 oxide reacts with ammonia to form copper plus nitrogen plus water. And in the second reaction, ammonia is removing oxygen from copper. So ammonia is acting as a reducing agent. Okay. Ammonia is acting as a reducing agent. Why? Because it removes oxygen from copper 2 oxide. Mariam, can you see on the equation?
Yes.
Okay. In the C reaction, third reaction, FeCl2 reacts with chlorine to makes FeCl3. So this chlorine here is acting as an oxidizing agent. We have already discussed this reaction. Chlorine is removing one more electron from this iron 2 to iron 3. So chlorine is acting as an oxidizing agent. So basically answer for this question is C. That is C. Over here, chlorine is an underlying element that is causing oxidation of iron 2 to iron 3. Okay.
Okay.
Okay, beta. And D, SO2, I told you SO2 is a reducing agent. Or SO2 is a reducing agent. So D cannot be the answer. Question number 9. In which equation is the underlying element reduced? And which equation is the underlying element reduced? Ji beta. This is very simple question. Mariam and Abdullah, try to answer this question, beta.
Sure. Which is is it A?
It is A. Very good, Abdullah. Very good. Very good. Copper from copper to sulfate has reduced from copper to ions to copper. So this is a reduction. It's a redox reaction and copper to ions are being reduced. So answer is A. Very good. Very good, Abdullah. Now we have some structured questions from past paper exams. Okay. This is purely IGCSE and very common GC question as well. Okay. Chlorine is in group 7 of the periodic table. Chlorine react with aqueous potassium iodide to form potassium chloride and iodine. Describe what you would see when chlorine is added to aqueous potassium iodide. Mariam, read this question once again and try to answer, please. What you would see, what you would observe is same thing, okay? It means that during this reaction, potassium iodide solution will turn from colorless to brown. Ji Mariam, did you get this or not?
Yes, sir.
Because chlorine is an oxidizing agent that will oxidize iodide ions into iodine. Okay, so you would say here that the solution, colorless solution of potassium iodide will turns from colorless to brown. I can write the equation for this reaction here, beta. I'm going to write the ionic the full equation for this reaction. For example, you have Ki and its aqueous solution. If you react chlorine with it, it forms KCl plus I2. Okay.
Okay, sir.
Okay,
This
sir.
solution I told you that is colorless. All group 1 metal compounds are colorless. Okay, but when iodine is formed in this solution, this whole solution turns brown due to formation of this iodine. Okay, so this is the displacement reaction in which more reactive halogen chlorine is displacing less reactive halogen from its compound iodine. So iodide ion changes into iodine from colorless to brown. So this is the observation. This you would observe when you carry out this reaction in the lab. Okay, beta?
Okay, sir.
Next question is, write the equation for the reaction between chlorine and potassium iodide. I have just written, okay. This is the equation, beta. This is the equation which we have just work it out. Potassium iodide, when chlorine is bubbled through it, it makes potassium chloride colorless solution, but iodine is formed in this solution, so it whole of the solution turns brown. So when you bubble chlorine gas in this solution, you will observe that it will turn brown. It start turning into brown or dark brown. Okay. Clear, Abdullah?
Okay.
When chlorine reacts with potassium iodide, iodine molecules are formed. Here, I2 molecules are formed from iodide ion with the loss of electrons. So iodine is being oxidized. Iodide ions are being oxidized actually. Explain why the formation of an iodine molecule from iodide ion is an example of oxidation. 1 mark question, Mariam. Yes.
Because it's gaining
It's losing electron. Beta, oxidation is loss of electron. Beta,
losing electrons.
iodide ions are losing electron here. If the electrons are shown in the product side, it means they have lost. Iodide ions are losing electrons to make iodine. Loss of electron is oxidation. Oil. I have told you, remember this with this phrase, this verb, this word oil. O-I-L, oil. Oxidation is loss of electron. Okay?
Yeah,
Okay,
yes, sir,
beta.
I meant that.
Sorry, beta.
I meant to say that.
Okay, I know you forgot. You try to answer quickly, but you forgot. Okay, no problem. So you should keep in mind that loss of electron is always oxidation. Now, question number 11. Aqueous copper 2 sulfate react with aqueous potassium iodide according to the equation shown or below. Cu2 plus ions, they are in the form of ions when you add iodide ion solution in it. Copper 2 iodide will be formed and iodine is also formed. So that is copper 1. Okay, this is copper 2, this is copper 1 iodide. Okay, copper 1 iodide. Okay, beta. CuI. If it is copper 2 iodide, then you can write CuI2, but this is CuI, so this is copper 1 iodide. Okay, okay, beta.
Okay.
Okay, sir.
So identify the reducing agent in this reaction. Explain your answer. Which is the reducing agent? Copper ions are being reduced beta by gaining electron, because initially there was +2 charge on the copper, so oxidation state of the copper was +2 over here, but in the product side it is +1, so it has decreased because electrons are being gained by copper 2 ions. These electrons are given by iodide ions, so iodide ions are acting as reducing agent. Okay, beta.
Okay, sir.
Okay, iodide
Okay.
ions are reducing copper 2 ions into copper 1 ion. So iodide ions are reducing agent. Okay. Did you get this or not, Abdullah?
Yes, I get this.
Okay, very good. Describe briefly how acidified potassium magnate 7 can be used to test for a reducing agent. This is very important, very common question, and we have just done this today. And in the last class, we did this as well. What is the color of potassium magnate 7, beta? Mariam? Acidified potassium magnate 7 is purple in color, beta. It's purple in color. I told you potassium magnate 7 came in 4 is purple in color. When you react it with the reducing agent, its color will change from purple to colorless. क्या color change observe करेंगे आप लोग?
Purple to color.
Purple to color. Abdullah, you need to remember this, beta. Purple to colorless. Purple to colorless. Okay. Aqueous chlorine is an oxidizing agent. Aqueous chlorine is an oxidizing agent. Describe how acidified potassium magnate 7 can be used to test for reducing agent. So you would say that potassium dichromate magnate 7 solution will turn from purple to colorless. Aqueous chlorine is an oxidizing agent. How can you prove this? Beta, when you add chlorine solution to a solution of potassium iodide, the solution of potassium iodide will turn from colorless to brown. Colorless to brown, okay?
Okay, sir.
Beta, look at this. I'm going to write this equation once again. I think I am writing this equation third time. Ki, that is a colorless solution. When you add chlorine aqueous solution in it, it forms KCl aqueous solution. along with the formation of iodine solution. So this solution turns from colorless to brown. So chlorine is actually acting as an oxidizing agent. Okay, chlorine is oxidizing iodide ions into iodine. Iodide ions changes oxidation state from -1 to 0. So that is the oxidation, and that oxidation is caused by chlorine. So chlorine is an oxidizing agent. Chlorine is an oxidizing agent. Okay, Abdullah?
Okay.
That's good. That's good. Okay, and name the product formed and write an ionic equation for the reaction between aqueous chlorine and aqueous potassium bromide. Okay, in this case, basically this is the displacement reaction of halogens. I have already told you and we have discussed when we did the topic periodic table that more reactive halogen displaces less reactive halogen from its compound. So chlorine being more reactive will displace bromine from its compound. Okay, so name the product formed. Name the products formed. You would say potassium chloride and bromine. Which two products will be formed, beta?
Potassium iodide and bromine.
Yeah, where is iodine? There is no iodine here, beta. Potassium chloride and bromine. Read this question beta once again. Name the product formed and write an ionic equation for the reaction between aqueous chlorine and aqueous potassium bromide. Look at this. This is chlorine. This is potassium bromide. Okay, it forms potassium chloride plus bromine. Okay, this is how to balance this equation. Okay, so these are the two products, potassium chloride and bromine. How can you write an ionic equation? Cl2 plus 2Br negative changes into 2Cl negative plus Br2 that has zero oxidation state. So this has been reduced and this has been oxidized. So this is how the redox reaction and this is how the redox reaction, and this is how to write down its ionic equivalence. Okay, Mariam?
Okay.
So question number 12 onward, we will discuss in the next class, and you should try to do these questions by yourself, beta. Okay, I will send this worksheet to you, both of you. Okay.
Okay, sir.
Okay, beta. So please try to do all these rest of the questions. Okay. Mariam and Abdullah, both of you need to revise this topic once again from these notes, from your book, and whatever I have explained. Okay.
Okay, sir.
And I will share this video with you, and you should view this video, watch this video. Okay, beta?
Okay, sir.
Allah Hafiz. Thank you very much.